All right, so I wanted to cry just now because I just did this entire lesson and it didn't record it only recorded 14 seconds, and it's kind of a long lesson. So I have some of it up and I'm going to use that. I might be erasing some extras that I missed here. So you guys can pause the video and write in what you need to. So this is 7.04 geometry. It's quadrilateral proofs that we're going to be talking about. So the first couple we're going to look at, I'm giving you the quadrilateral, and I want you to, use its properties to prove something else. And then the other three proofs, so a lot of proofs, is those three are going to be actually proving the quad. So like proving a quad is a parallelogram, or proving it's a rectangle. Proving the quad is a rectangle, rhombus, or square, and you might have to use the fact that it's a parallelogram there. All right, so the first proof we're going to do is given ABCD is a rectangle, and a lot of these I do have to draw in the pictures again. So we're given, this is ABCD, and this point right here is M. So pause the video here, write down your givens, and draw your picture and your proof statement. All right, so first of all, we're given, I'm going to start with the second given here, that M is a midpoint of segment AB. So I can mark that off right away. The first given, there's actually a lot I can conclude from that, and I'm going to kind of make my plan to decide what I actually want to conclude. So ABCD is a rectangle, which is this whole thing. So what do I know about a rectangle? Well, I know opposite sides are congruent, so I know that these two sides will be congruent to each other. Before I continue on going, I could say opposite sides are parallel, opposite angles are congruent. Those are all true about any parallelogram. I know it has 4 right angles in a rectangle. The diagonals are congruent to each other. But before I start marking all of that, I'm going to kind of work backwards. So I know that I want to get segment DM, and I'm going to make that green. DM congruent to segment CM. So whenever I'm trying to get two segments or two pairs of angles congruent, I ask myself, are they a part of two different rectangles or two different triangles? And they are here. They are a part of triangle DAM and triangle CBM. So if I can get those two triangles to be congruent, then I could get those two green segments, segment DM and segment CM, to be congruent as well. So now let's figure out what we need in order to get those two triangles to be congruent. So I already marked that the pair of opposite sides were congruent, so that gives me a pair of sides. I know M is the midpoint, so that gave me a pair of sides in those two blue triangles. What else could I take from the fact that this is a rectangle that might help me get the two triangles to be congruent? And hopefully you're thinking about maybe the angles. So we know it has 4 right angles. So if those two are right angles, all right angles are congruent, I have enough to get the triangles congruent. How would those triangles be congruent? So which of those 5 reasons, side, 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 angle, angle, side, or HL? And in this case, hopefully you're saying it should be side, angle, side. So we have enough information to do this entire proof. I would love it if you could pause the video here and try to write that out on your own now. If you do need help, you can always check back, and if you make it through the whole proof, come back and check your answer. All right, so from here, I would conclude from my givens. So segment AM is congruent to segment MB, and I'll let you guys, hopefully you've written in a lot of this on your own. If not, I'm going to allow you to write it in. I'm not going to write everything out for you. So here would be definition of a midpoint, the reason why those two segments would be congruent. Now that gives me 1 pair of sides, so I can cross off, I have a pair of sides congruent, not equal, but congruent. All right, I also know, we said that angle A and angle B are right angles. So something you want to double check your papers for is that you didn't jump right to saying angle A is congruent to angle B. You first have to state they're right angles, then you can get them congruent because all right angles are congruent to each other. They're only congruent because they're right angles. So I'm going to write out the reason for 3. We would just say, in a rectangle, all angles are right angles. Now I can say that angle A is congruent to angle B because all right angles are congruent. All right, so now that gives me a pair of angles congruent. So I can mark that off. So I still need another pair of sides to be congruent before I can get those triangles to be congruent. So where am I getting my third pair of sides? So we marked off segment DA congruent to segment CB. And the reason there would be in a rectangle, opposite sides are congruent. Which gives me my other pair of sides. So now I've marked off 2 pairs of sides and a pair of angles. So now, since everything's crossed off, I have enough information to say that triangle DAM is congruent to triangle CBM by side angle side. Remember, just because it has a right angle in it, does not mean you have to use HL. HL is an option, but only if you have the hypotenuse congruent to another hypotenuse and a leg congruent to another leg. So that's side angle side. And then number 7 would be your CP, CTC. All right, let's take a look at another one. So number 2, I'm going to draw your picture here. So we know that AED right here is a segment. So that's just telling you that's a straight line right here. And FEC is also a straight line. That's what that's telling you right there. I'm overlapping here. All right, and we want to prove that segment FE is congruent to segment DE. So pause the video, copy down that picture. Move this. So part of your given segment FEC, just saying it's a straight line. I just want to get that out of the way so you can clearly see your picture here. It's D, and then I'm also going to put in 1, 2, angles 3, 4, moving point E here a little bit too. That's E, and then call those 5 and 6. All right, and pause your video, copy down your givens, your proof, your picture, and start even marking your picture on your own, making a plan for your proof. All right, so we know AECB is a rhombus. So this right here we know is a rhombus, which means all of the properties we know about a rhombus we can conclude here. We also know that FAB, so this entire angle is congruent to this entire angle DCB. And in green, I'm going to put that I want segment FE to be congruent to segment DE. So in order to get those 2 segments to be congruent to each other, I work backwards. I ask myself, are those 2 segments a part of 2 different triangles? The answer is yes, they are. They are part of triangle FEA and a part of DEC. So if I can get those 2 black triangles to be congruent to each other, and try to match up your corresponding parts. So I know those green segments I want to be congruent, so I'm going to kind of use that to match up my parts. So CDE would match up with AFE. So if I can get those 2 triangles to be congruent, then I can get those 2 segments to be congruent, the 2 green segments. So now the question is, working backwards again, how can I get those 2 black triangles to be congruent to each other? So here's where maybe I say, okay, right away it tends to pop out at us that we've got vertical angles. So I know I can get a pair of angles there. I know this is a rhombus. What do we know about all rhombi? Well, all the sides in a rhombus are congruent, so I can mark all 4 sides congruent. by doing that, I notice that these two sides are two consecutive sides in the rhombus. Those are going to be congruent. They're also part of those triangles. So now I have an angle and a side. I have not used my other given yet, that angle FAB is congruent to angle DCB yet. That's not saying 1 and 3 are congruent yet. I only know those whole angles are congruent, which they're not a part of those black triangles. So how could I get just angle 1 congruent to angle 3? If I can do that, then how could I get my triangles to be congruent? Hopefully you're saying angle, side, angle. So now the question is, how do I get angle 1 congruent to angle 3? And pause the video, think about it, see if you have a plan to do that. Hopefully you were thinking if you have a whole congruent and then you know that in a rhombus or in any parallelogram, opposite angles are congruent. So I could get angle 2 congruent to angle 4 because opposite angles in a rhombus are congruent, and then I can use my subtraction to subtract 2 and 4 from the whole angles, leaving me with angle 1 congruent to angle 3. So using angle subtraction, subtraction property equality, substitution, your 3-step process to do that. All right, go ahead and try writing out as much as you can of your proof and see how far you can get, and then check back with me. All right, so hopefully you have in here that angle 5 is congruent to angle 6. Again, you could, I'm not going to write out everything here, but you could write your vertical angles are congruent. It's something I think most of you probably were able to get. Let's, and then let's do, while we're here, segment EC congruent to segment EA. So your reason for that would just be in a rhombus, all sides are congruent. We're not concluding about all the sides, we're just choosing 2 of them, the 2 that we need, but that's the reason all sides are congruent. All right, now let's focus. So actually, that gives us a pair of angles congruent and a pair of sides congruent inside of our triangles. So all we need now is our last pair of angles. So that's what we're going to get by doing our angle subtraction. So now let's start that process. In order to do that process, I know I'm going to need 2 sets of equals. So I'm going to take my wholes and set those equal, because right now they are just congruent to each other. And my parts, which are measure of angle 2, I'm going to set equal. Oh no, I don't have that yet. Sorry, this is the problem, because I just did these proofs. I forgot that I haven't actually done it in the proof this time. All right. Back up for just a second. Before that step, we need to say angle 2 is congruent to angle 4 because we don't, and this is why it's important to write out those 2 sets of equals. Now I know I need those parts equal and I need a set of wholes equal. So here our reason would be in a rhombus, opposite angles are congruent. And even if you said in a parallelogram, opposite angles are congruent, all of that would be the same. Now I'm going to say that my wholes are equal. And now I have my parts equal in step 4. And that's just going to be your definition of congruency. All right, so now I have 2 sets of equals. Now we can start our 3-step process. So to do that, I'm going to take the measure of angle FAB. And again, if you haven't done this yet on your own, and now you feel like you're at a point where you can take it on your own, which you should all be able to do this, pause the video and finish this part up on your own. So a measure of angle FAB minus the measure of angle 2 equals the measure of angle 1. Measure of angle DCB minus the measure of angle 4 equals the measure of angle 3. And that's your angle subtraction postulate. Step 7 would be now taking your 2 sets of equals here and subtracting equal amounts from equals are equal. So measure FAB minus the measure of angle 2 equals the measure of DCB minus the measure of angle 4. And that reason would be your subtraction property of equality. And now if I know measure of FAB minus measure of angle 2 equals the measure of angle 1, I could sub that in right there. And likewise, I can sub in measure of angle 3 for DCB minus the measure of angle 4. And that would, reason for that would be your substitution. Now I don't have a pair of angles congruent yet, I just have them equal, so I'm going to switch this back to congruency. And the reason there would be def of congruency. And now I have my other pair of angles, so let me cross that off. By crossing that off, I now realize I've met all three requirements here. So once I have those three, I have a pair of angles, a pair of sides, and another pair of angles congruent. I can say segment CDE is congruent to triangle. Sorry, I said segment. So triangle CDE is congruent to triangle AFE by angle, side angle, and then I can say, my numbering's off a little bit here, so this was 9, depth of congruency, 10, angle, side angle, and 11 is your last step, which will be your CPCDC, because those are two corresponding parts of those two triangles.